All right, and now for number 3, we have that on a Monday, happy Monday, at an amusement park, a sample of 40 visitors was randomly selected as they were leaving the park. And all these homies, they were asked how many times a day they had been on a ride called, whoa, the Dragon. The information is summarized in the following frequency table. So let's first understand this frequency table and what it means. So, for example, one of the persons they interviewed for the number of times they were in the Dragon, he answered 0, right? Now, how many people answered 0? 6 people answered 0. Of the 40 visitors that were surveyed, of those 40, the ones that rode only once were 16. The ones that rode exactly twice were 13. The ones that rode exactly 3 times were 2. And the ones that rode exactly 4 times were 3. Okay, that is a better explanation than to what I was about to do. So that's the frequency table. Okay? It can be assumed that this sample is representative of all visitors to the park for the following day. All right, so for the following day, we can basically estimate using the same table. So we can trust the table as a good representation. So for part AI, we need to find the probability that a randomly selected visitor will ride the dragon. See? So guys, for probability, the name of the game is always the same. So for probability, it's your total cases in the bottom. So total cases. And up top, it's possible cases for what you're trying to find the probability of. And so the probability of ride is going to have all the possible cases. So all that ride divided by the total cases, which is all that went to the park. See? So intuitively, I can state it like this. Basically, you just need to sum all the possible cases divided by the total cases. So all the possible cases, right, of those that rode is going to be these, and these. And your total is going to be these. Okay? So notice, for the total, it's that in red. And for the possible cases, it's just the ones in orange, in red, in blah, in green. Okay? So technically, I can do 16 plus 13 plus 2 plus 3 divided by 6, which includes this guy, plus 16 plus 13 plus 2 plus 3. So you can spend some time doing math, but eventually you're just going to find that you have 34 divided by 40. And so that is one way to do it. The other way to do it, which is a more like quick maths sort of approach, if you want to cook this for a little bit, you can see that they tell you that it's 40 visitors. So your total has to be 40. All that went to the park were 40. And they're only asking for those that will ride the dragon. So which ones don't ride the dragon? 6 of them don't ride the dragon. So you can do 40 minus 6. It gives you this 34. See? So that is a slightly quicker way to just find 34 over 40. See? I don't know if it's that much faster, but I do want you to see it as an option. Okay? Anyways, for part AI, the answer is 34 over 40. That is a probability that they will ride the dragon. So let me make a little bit of space over here. And let me just write that real quick. The answer for part AI is 34 over 40. For part A double I, we need to find the expected number of times a visitor will ride the dragon. And so here we enter what we call expected values, expected number, expected. And so the big word, the big buzzword here is expected. Now, once you find the expected thing, okay, once you realize that they're asking for expected, it's suddenly very easy to do this. See? So all you need to do for expected is just a very visual approach. See? So you're going to be doing, for example, this times the probability of that. This times the probability of that. This times the probability of that, so on and so forth. Now, how do I know that you need to do this? I know this because it's actually in your formula booklet. So in your formula booklet, if you eventually find expected value, here it says, expected value of a discrete random variable x. Discrete, you guys, is just like a whole number, okay? And so here you have a bunch of whole numbers, 1, 2, 3, 4, right? So that's why you know you can use this. Now, what is this saying? It's basically the sum of your, it's going to be the sum of your x's times the probability of each x. So it's going to be each x, it's going to be the sum of all of these, right? The sum of your x times the probability of getting that x. So now it's a little bit more friendly because, okay, so basically it's just, for example, for this first one, it's 0, because that is my x, right? Times the probability of getting that x. Now the probability of getting that x is, so it's going to be 0. The probability of writing 0 times is 6 over 40, because the frequency is 6, right? And for the next one, because we're adding, right? It's a summation. See, we're adding. So this is for the first one, right? Then for the next one, we have that it's, okay, writing once, what's the probability of that? So writing once, the probability of that is 16 over 40. 16, because this is frequency 16. All right, interesting. So you can keep going from here. Plus 2 times, so what's the probability of writing exactly twice? 13 over 40. And you keep going and you end up with something that looks like this. So for 3, it's going to be 2 over 40. And for 4, it's going to be 3 over 40. Okay, because of this 3. And so that is for the expected values. If you do all the math, you're going to get the right answer. Now, I know some of you might be thinking, you're trolling. Why did you put this 0 over here? And I put it just to follow the procedures, just to show how you're supposed to do it. See? And so for this first one, yes, it ends up being 0. It doesn't really matter. But I would rather just show you the whole process. Okay? So on the one hand, that happens with that. This next value ends up being with 1 times this is just 16 over 40. Then the next one is 2 times 13, so it's going to be 26 over 40. Plus 3 times 2 is 6 over 40. Plus 4 times 3 is 12. Whoops. 12 over 40, right? So you go ahead and add all of these. It's pretty friendly because they're all in denominator with 40, so you can add them as a fraction. So you end up with 16 plus 26 plus 6 plus 12, all under the same 40, right? And this, with a little bit of quick maths, ends up being damn, I cannot math right now. So that is 18. Then that is yeah. It ends up being 60 over 40. Okay? And so 60 over 40, if you were to, simplify this a little bit, on the one hand, they both have a 0 on top, so you can do boom, boom. You end up with 6 over 4. They're both even, so you can leave it as 3 over 2. So I'm going to leave it as 3 over 2. Okay? So for part A, double I, the expected number of times a visitor will ride the dragon is 3 over 2. If you want to get fancy, this is the same as 1.5. Okay? I'll leave it as a fraction because whatever. See, we're working with fractions. Then they tell us that it is known that 1,000 visitors will attend the amusement park on a Tuesday, and the dragon can carry a maximum of 10 people each time it runs. And so we need to estimate the minimum number of times the dragon must run to satisfy the demand. So let's take a moment to think about this. See? Usually for the IB, not always, but usually, and it's a big hint, what you do in part B needs something from part A. It's not always the case, but a lot of times it is. Okay? And so here, part A double I is something directly needed for part B. Okay? So, the expected number a visitor will ride the dragon, we said was 3 over 2. Okay, we said it was 1.5. And so, technically, if 1,000 people show up, then how many times will they ride the dragon? Well, one person, so one visitor, rides 1.5 times. So 1,000 visitors, you need to multiply this by 1.5 to find the amount of times that the dragon is ridden. And so 1,000 times 1.5, right? Well, quick maths, you end up with 1,500, okay? There's a chance that you kept it as fractions and you didn't realize the decimal, so you can leave it as times 3 over 2. This is just going to be 1,000 over 1, right, times 3 over 2, because for fractions that multiply, you multiply straight across. So I put a 1 over here just to make it more visually appealing. You end up with 3,000 divided by 2. This gives you the same 1,500. So this 1,500, you guys, let's leave very clear, is number of times the dragon is, I actually don't know the right word here, is ridden, is rode, is used, okay? So that is the number of times the dragon is used. And because the dragon can carry a maximum of 10 people, the minimum number of times it has to run to satisfy the demand is 1,500 divided by 10. So if you divide by 10, because they both have a 0, you can do couple out, 150 times. So that is for part B, and that is for number 3.